Hello, welcome back. Before we get too much into sports nutrition, we first need to discuss your energy systems. Now, your energy systems are dependent on how long you're exercising for. For example, weightlifting depends on ATP and it lasts generally up to about 2 to 4 seconds. Following that, there's a ATP phosphocreatine system which kicks in, recycles ATP for energy over the first 30 seconds and covers 100 meters or 200 meters of sprinting. Beyond that, the lactic acid pathway creeps in for the first few minutes of exercise. And beyond that, you have to slow down a little bit, and your exercise is entirely dependent on aerobic metabolism and using oxygen to support and to burn glucose and carbohydrates to support your exercise activity. Yeah, so taking a quick look at your energy systems, there is approximately 5 kilocalories of ATP phosphocreatine in your system. There's 80 kilocalories of blood glucose. You store in your liver and your muscle nearly 2,000 kilocalories worth of muscle and liver glycogen. This will get you through about 2 hours of intense aerobic activity. And then for longer duration racing and training, you'll be dipping into fatty acids, particularly the muscle triglycerides, and eventually the adipose tissue. That's your fatty tissue. With long-term exercise, you will also start to degrade muscle protein. This is of concern when you're training because that's counter to the effects that you want with training, where you want to build and strengthen muscles. Okay, yeah, taking a visual look at your energy system. First, you burn ATP in the cells of your muscles. Phosphocreatine then can recycle ATP out to about 30 seconds. Between 10 seconds and the first minute or two, anaerobic glycolysis takes over, producing lactic acid. And beyond that, aerobic metabolism, which is oxygen burning glucose, kicks in. And as this starts to get depleted around the 2 hour mark, fat metabolism begins to take over. So your Ironman, ultra runners, long distance runners of all kinds are starting to rely very heavily on aerobic metabolism of fats to sustain their exercise levels. Okay, let's take a closer look at these systems. ATP provides this usable energy in the first 2 to 4 seconds. That's like lifting very heavy weights. Phosphocreatine provides this energy for 30 seconds and is recycling ATP. Phosphocreatine is made from amino acids, and you can boost this energy system by directly consuming creatine in your diet or supplementing with creatine in your diet. And that will provide you energy for this 30-second type efforts. If your sport requires bursts of energy or approximately 30 seconds duration over and over again, then boosting your phosphocreatine supplies by supplementing with phosphocreatine is a reasonable idea. Next, we're looking at lactic acid production for the first 1 to 2 minutes of exercise. Glucose is broken down into pyruvate, and when this happens, 2 ATP molecules are formed to power your muscles. And in the absence of oxygen, lactic acid is produced. Most people call this feeling the burn of lactic acid building in their muscles. You'll notice this when you run 400 through 800 meters at high speed. They get this massive lactic acid buildup. Now for exercise longer than that, aerobic metabolism kicks in. Aerobic metabolism is very efficient, can produce 28 to 30 ATP molecules compared to the 2 molecules that can be produced here by glucose breaking down into pyruvate. But pyruvate can be broken down into acetyl-CoA, generating these 28 to 30 ATP molecules. However, this requires a continual supply of oxygen, so it's very dependent on optimizing your cardiovascular function. That's what we need for long-distance training. The other system for even longer-term exercise is metabolism of fatty acids. Fatty acids can be broken down into ketone bodies and can provide energy to your muscles. Now, fat burning produces 129 ATP molecules, and it produces much more energy than carbohydrate burning. However, fat burning is much more oxygen dependent than carbohydrate burning. And here you can see why. This is a molecule of glucose. In red, you can see the molecules of oxygen, and in black, you can see the molecules of carbon. So when we're burning glucose to form carbon dioxide, you need just 1 extra oxygen per carbon to do that. Now with a fatty acid such as palmitic acid here, you can see there are a lot of carbons here in this chain, very little oxygen. So you require a great deal more oxygen to burn palmitic acid and other fatty acids. In this case, the fat contains only 1 oxygen for every 8 carbons. So burning fat requires much more oxygen and a very highly developed cardiovascular system. So for peak performance, you need to train and fuel both your cardiovascular and your respiratory systems. That's your heart, your lungs, optimizing the volume of your veins and arteries, improving lung function, lung volume, and having all of your airways and air passages open to provide as much oxygen to your muscles as quickly as is obtainable. Thanks. I hope that's a good introduction to the requirements of your body in terms of energy. I look forward to talking to you specifically about the nutrition you need to do that in the next talk. This is the references and disclaimer page. The reference textbook that most of these videos follow is Understanding Nutrition by the authors Rolfs and Whitney. I use the 15th edition by Cengage Publishing. Please subscribe to my YouTube channel. It's called Nutrition, Fast and Fun. There's lots of great videos that you'll find there. And finally, there's a medical disclaimer. You should read the medical disclaimer to make sure you fully understand your rights and responsibilities. Thank you and have a great day.